Find general solution. In part A, we got dy over dx equals 1 over xy. X is independent variable and y depends on x. X is never 0, but y can be 0. But in this question, we got 1 over xy. Y is also on the bottom, so y is not 0. That's assumed. To solve means we need to isolate y. So y is given in terms of derivative. So at some point, we need to integrate and get y by itself. So this is given in derivative form. First, we write this equation in terms of differentials, so which is kind of cross multiplying. So writing in differentials. So we get xy dy equals dx. Now we want to leave function of y dy in the left and function of x dx on the right. So we need to move x to the other side. So it's a times. So we divide both sides by x. So when we divide both sides by x, we get y dy equals 1 over x dx. Now we integrate because we separated the variables y, function of y dy, function of x dx. So we integrate now. Then we get that antiderivative of y is just y square over 2. Okay, and in the right side, antiderivative of 1 over x is just natural log of absolute x and plus some constant of integration. Next, we need to get y by itself. So there is a 2, so we can multiply through by 2. Okay, let's multiply through by 2. That leaves y square equals 2 ln x and 2c. So we can write 2c, or we could have written just c1, and when we multiply by 2, 2c1 is another constant, and we can just write c. Or we can write just always 2c. And finally, to get y by itself as a square, so we take a square root of both sides. So y equals square root of 2 ln x plus c and plus or minus. Okay, that's A. Here's a B, but let me do C because it's here. Same thing. X is never 0. X is independent variable. Y is dependent on x, and y can be 0. So here, if you look at closely, y equals 0 is a solution. We are not interested in this solution, but if we plug in y equals 0, derivative of 0 is 0, and 0 times ex is 0. So y is also a solution. So the main focus here is what if y is not 0. Then we can write this in terms of differentials, which is kind of multiplying. dy equals y ex dx. Now here's y, so we need to bring this y, function of y, to the left. So we divide both sides by y. We get 1 over y dy. So we are dividing by y, and that leaves ex dx. Now we separated the variables. Function of y dy in the left, function of x dx in the right. So we integrate. So when we integrate now, 1 over y, that's natural log of y, and ex is just ex plus c. Okay, now we need to get y by itself. So to isolate, exponentiate both sides so that we can cancel ln, because ln and exponential, just the e base, exponential are inverses. So e raised to whole in the left hand side, e raised to whole thing in fact. Okay, e raised to whole thing in the right hand side. Then e and natural log cancel, we get y, absolute y equals e raised to whole thing. If you want to separate, what happens is, like when you have x raised to a plus b, that is x raised to a times, not plus, x raised to b. Same base, we add the exponent. So here we can write e raised to ex times e raised to c. Okay, if we say, let's say c1, so e raised to c1, where e is already a constant, and we can say, oh, just a constant c in this case. Okay, now we are not done because it's still absolute y. So when we get rid of absolute value, that gives plus minus. So plus or minus e raised to c1, I'm going to write here e raised to c1 constant first, e raised to ex. And in fact, we can simplify a little bit, which is not needed. Plus or minus e raised to c1, which is a constant, plus or minus, but okay, we can just call a constant c. If we do that, then the solution is now y equals constant e times e raised to, sorry, not times, e raised to ex. Okay, here is v, same thing, dy, we can cross multiply. That is, in fact, we are not really cross multiplying, but we are writing in terms of differentials. But I want to move dx to the other side, and that will separate the variables. So I'm going to leave 1 over 1 plus x squared, which is a function of x in the right hand side, and just simply move x. So we separated the variables. I mean, there's 1 dy and function of x dx. Okay, the next thing is, once we separate the variables, we just integrate both sides. Okay, so in this case, dy just y is 1. And what is antiderivative of this fraction? I mean, there is no fraction rule, but this one is a special fraction, and we know that derivative of arctangent or tangent inverse is 1 over 1 plus x squared. That means antiderivative of 1 over 1 plus x squared is arctangent or tangent inverse x plus some constant, and y is already isolated and done. And here comes part d minus, so we need to move this term to the other side first. We are trying to isolate or separate variables first, okay? Trying to separate variables, then integrate and isolate y. So we got dy over dx minus means add y square cosine x both sides, so that gives you y square cosine x. Now this dx should be moved to the other side and y square to the left side, basically separating variables. Y square bring to the left, it's a times, so it becomes 1 over y squared. I'm just going to leave dy. We should never write dy on the bottom, it doesn't help. Now dx to the other side, we got cosine x already there, dx. Now we separated the variables, function of y dy, function of x dx. Now we integrate, and that gives us 1 over y squared, is move up y to the negative 2 and do the power rule, that's negative 1 over y, equals antiderivative of cosine x is just sine x plus constant. Okay, now we need to isolate y, get rid of negative, so we can multiply through by negative 1. So 1 over y equals negative sine x minus c, or we could have written c1, that gives us negative c1, and we can call, oh, that negative c1 is plus c. You can always just work on minus. Now take reciprocal of both sides, because that's how we can get y on the top. Take reciprocals of both sides, so we can flip this y. Reciprocal means in this case we got all over 1. Now we need to write 1 over everything. We cannot separate the minus sine x plus c or c minus sine x, and that's final answer. So y as a function of x is given by this final.